In this movie, we're gonna study how to think about public good game with FS model. So studying public good game with FS model is slightly complex because there are many players in this game. So in public good game, let's say there are n players. So n players, number of n players play this public good game together. And let's use FS model to think about public good game. So this means utility function of ice player is, so there are n players, so first player, second player, and so on. And let's think about ice player. So so if I is number 1, it means first player. If I is 3, it means third player. So think about ice player in this public game. So MI stands for monetary payoff. So this is a user payoff in public game. So here MI is user payoff in public game. So MI is income. So individuals' income in public game. So we assume all players in this public game have same amount of income Y. And GI is player I's expenditure for public good. RG, this is benefit from public good. So large G is total amount of public good in this group. And out of this public good, this individual obtains benefit with the rate R. And we know that R is a number less than 1. So this is the user payoff in public good game. And if there is punishment, we can add more terms here. So for instance, if there is punishment, we can add punishment cost. So for each unit of punishment, individual I has to pay cost C. So here Pij indicates the amount of punishment on individual J. So for instance, P23 means this is an amount of punishment on individual 3 by individual 2. So this is punishment cost, and here the last term is, this is the punishment on individual I. So this last part represents the punishment imposed on individual I by other individuals in this game. So if there is punishment, we can add these terms, and if there is no punishment, we don't have to worry about these terms. So in this movie, we're gonna think about the case without punishment. So let's not worry about punishment part. So MI So here MI represents user payoff in public good game without punishment. And in FS model, we have to think about inequality. So first we can think about NV part. So here comes NV parameter alpha. So this term here represents the amount of inequality between individual I and others. So this red part represents so other individual J. So if other individual J has more material payoff than individual I, we can say there is inequality between J and I by this much, and this is the source of envy for individual I. And we can now think about compassion part. So this red part here is the amount of inequality, and in particular here, if this is positive, it means that individual I has more material payoff than individual J. So this part of inequality is going to be the source of compassion for individual I. So using the definition for MI, so we replace MI by using this definition for material payoff in public game. So instead of MI, we write down this expression, and instead of MJ, using the similar expression, we can say MJ is Y minus GJ plus RG. So we replace MI and MJ using this payoff expression for public good game. Then we can rewrite individual I's utility as follows. So instead of MI, we have this expression for public good game. And for NV part, so instead of MJ and MI, now we just have so if we look at the NV part, instead of MJ and MI, now we have GI and GGA. And make sure subscript is changed from J minus I to I minus J. So when we compare material payoff between individual I and individual J, we know that Y and R times G, these terms appear in both MI and MJ, so they cancel each other. So the only remaining term is expenditure for public good. So in this public good game, the source of inequality between two individuals comes from this difference in expenditure for public good. So as we can see in this green expression, we can see that if I spend more for public good than individual J, then this is gonna be the source of envy because I spend more for public goods, so eventually my material payoff is gonna be lower. So I'm gonna feel envy for individual J. Similarly for compassion part, we have difference between GJ and GI. So as this blue expression tells us, the source of compassion comes from the difference in expenditure for public good. So if others spend more for public good, so if this is positive, so individual J spends more than individual I, then because of higher expenditure for public good, eventually individual J is gonna have lower material payoff than individual I. So this is gonna be the source of compassion for individual I. So in this public good game, when we apply the tools from FS model, now we can see this the source of inequality comes from this difference between expenditure for public good across individuals. So if someone spends more for public good, then he's likely to feel envy because higher expenditure for public good is gonna reduce his material payoff. And if someone spends less for public good, then this individual is likely to feel compassion for others because his payoff is gonna be high. So using this expression for utility function, we can talk about free riders. So using this utility function, we can talk about free riders. In particular, we can talk about who are these free riders in this public good game. So one thing we can say is if beta is very small, so if we can identify those individuals with low beta parameters, then they are likely to be free riders in public good game. Now in particular, we can say if beta is smaller than 1 minus r, so here R, this is the rate R here. So this is the rate of benefit from public good for each individual. So if beta is less than 1 minus R, then we can say that such individual is gonna free ride. So he doesn't want to contribute to public good at all. So how do we know? So this is the intuition. If this individual with beta less than 1 minus r, if he contributes 1 unit of public good, so he contributes 1 unit of public good, then it means that his expenditure for public good goes up by 1. So his contribution to public good goes up by 1. So this means monetary cost goes up by 1. Because as we can see here in this part, so his expenditure goes up by 1. So his monetary cost goes up by 1 if he contributes 1 unit of public good. But but we know that he's gonna get some benefit from public good with the rate R. So if we contribute 1 unit of public good, this total amount of public good goes up by 1. So he's gonna get benefit by R. So therefore, cost goes up by 1, but benefit also goes up by R. So if we add these two, we can say cost goes up by 1, but benefit also goes up by R. And here we know that R is less than 1. So we can say total cost goes up by 1 minus R. So total here, total cost goes up by 1 minus R. And now we have to think about inequality. So here 1 minus R, this is the change in material pay of part. So in other words, change in here in this blue area. And now we have to think about the change in inequality. So if this individual with beta less than 1 minus R contributes 1 unit of public good, what's gonna happen to inequality? Because he's contributing more to public good, this is gonna increase NV. So this is gonna increase NV. So he spends more for public good. Therefore, eventually, his material payoff is gonna be lower. So this is gonna increase NV. But at the same time, it's gonna reduce compassion. So it's gonna reduce compassion because now he spends more. So his material payoff is gonna be likely to be lower than others. So now he's gonna feel, he's gonna less likely to feel compassion. So higher NV is bad, lower compassion is good for his utility. So the maximum possible benefit he can get from inequality change is the reduced compassion. So suppose if n change in NV is 0 and there is only lower compassion in inequality change, then this is the maximum possible gain he can get from inequality change. So in this case, he can get benefit beta. So if there is 1 unit change in compassion, then we can say there is benefit by beta. So increasing cost by 1 minus R, this is bad. But because of reduced compassion, he's gonna get additional benefit beta. So if beta is less than 1 minus R, we can say that this benefit from reduced compassion cannot compensate the increase in cost 1 minus R. So therefore, such individual with beta less than 1 minus R is not willing to contribute 1 unit of public good. Therefore, such individual is gonna want to such individual wants to contribute nothing. So eventually, he's gonna free ride by having contribution equal to 0. So let's think about this intuition with example. Suppose n is equal to 3, so there are 3 individuals in this public good game. Suppose first individual's expenditure for public good is the highest, and second individual next, and third individual is contributing the least. And let's suppose, so we're gonna think about second individual's utility. And let's assume if second individual lowers his contribution to public good by 1, then his second individual's total contribution to public good becomes the least. So we can say G1 is here, and G2 is here, G3 is here. So currently, second individual is contributing more than third individual. But if second individual reduce contribution by 1, then now he's here. And in this case, third individual is contributing more than second individual. So let's think about this kind of situation for simplicity. So in this case, if second individual contributes, so we're gonna think about second individual's utility if second individual contribute G2. In this case, second individual's utility is equal to, first material payoff is, so income Y minus contribution G2 plus R times total public good. So total public good is equal to, so total public good is equal to G1 plus G2 plus G3. So this is material payoff. Now we're gonna think about inequality. So first, NV part. As we can see, second individual is gonna feel envy for third individual because, as we can see here, second individual is contributing more than third individual. So second individual, so here instead of, so not just alpha I, alpha 2, so second individual's alpha. So second individual is gonna feel envy about third individual because he's contributing more than third individual. And beta. So as we can see here, we know that second individual feels compassion about first individual. So this is what we get. This is second individual's utility. Now, in this case, what if second individual reduces his contribution by 1 unit? So here, instead of G2, now second individual is going to contribute G2 minus 1. So he's going to reduce his contribution to public good by 1 unit. So here we are thinking about moving from G2 to G2 minus 1. Then in this case, second individual's utility is going to be equal to, so income Y minus contribution is G2 minus 1 plus so R times total public good is equal to, so this is previous amount of total public good. Now we have to subtract 1 unit. So total public good is now 1 unit less in this group. And in this simple situation, in this example, we can see that second individual is gonna feel compassion about first individual and third individual. So we only have beta. And here inequalities, inequality between first individual and second individual. So this is inequality between first and second individual. And inequality between third and second individual. So this is the expression for second individual's utility if second individual reduces his contribution by 1 unit. So if I subtract, so let's say this is number 1 and this is number 2. So number 1 minus number 2. So we want to calculate the utility change. So we're gonna show that number 1 is bigger than number 2. So in other words, for second individual, his utility goes up if he reduces his contribution to public good. So therefore, eventually this is gonna mean that for second individual, it's better to reduce contribution. Therefore, eventually second individual is gonna choose contribution equal to 0. So therefore, he's gonna free ride. So let's see. So if we subtract, so number 1 minus number 2, we have for material payoff part, we have 1 minus R. So if you subtract this, and these two terms, we can see that for material payoff part, we have 1 minus R. So in terms of material payoff, we can see that second individual's utility increases. So this is very obvious because in terms of monetary payoff, these individuals lose when they contribute to public good because the benefit from public good is discounted by R and R is less than 1. Therefore, in terms of material payoff, it's obvious that individuals' utility increases when they reduce contribution. Now let's think about inequality change. So if we subtract number 2 from number 1, eventually we get this expression. So this is the utility change. And so if you look at this green segment, so if you look at this green segment, the distance is equal to 1. So the distance, so if you look at this length of this green segment, the length is equal to 1. Therefore, it means in this example, the distance between G2 and G3 is less than 1. So distance between G3 and G2 is less than 1. Therefore, so here, so this is a negative number. So this is a negative number, but magnitude is less than 1. So for example, this is something like minus 0.5. So G3 minus G2, this is a negative number, but the absolute magnitude is less than 1. So it's something like minus half. Therefore, we know that this parenthesis term is a positive number, but this is less than 2. So this parenthesis term, this red part is a positive number, but it is a number less than 2. Therefore, if you divide by number 2, we know that this is gonna be positive number, but less than 1. Therefore, so if I change this red part to number 1, we know that expression is gonna be lower. Okay, then we are done. This is a positive number, so we don't have to worry about that. And now, so this blue term is positive number. So if I subtract this blue term, I get this expression. So beta 2. So as we said before, if we use this inequality, so if we think about some individual with beta less than 1 minus r, so if this individual is someone with beta less than 1 minus r, we know that this is positive. Therefore, it means utility change is positive. So it means number 1 is bigger than number 2. Therefore, it means for this individual, lowering contribution to public good increases utility. Therefore, such individual is willing to reduce contribution to public good. Therefore, he's gonna free ride on public good contribution. So he's gonna choose contribution G equal to 0. So we can say. So free riders, if beta is sufficiently small, so in other words, if beta is less than 1 minus r. So we found a condition for free riders. So we found a condition for free riders. So who are these free riders? So free riders are those individuals who feel very small amount of compassion. So they don't feel compassion that much about other individuals. Then these are those individuals who are likely to free ride, so they are willing to contribute very small amount to public good.